Hi statistics students, I'm going to go over two proportion confidence intervals on the calculator. It's not perfect, there's still a few rounding errors, but it's fairly easy, I think. So here's a question from section 6.8. Are errors less likely with electronic prescriptions? Errors in medical prescriptions occur, and a study examined whether electronic prescribing may help reduce errors. Two groups of doctors used written prescriptions and had similar error rates before the study. One group switched to e-prescriptions while the other continued to use written prescriptions, and the error rates were measured 1 year later. So we can call this an experiment because we have controlled the situation. Find a 90% confidence interval for the difference of the two proportions between written and electronic. So we have written errors and proportion of errors using e-prescriptions. Round your answers to 3 decimal places. Okay, so this one's given us all the numbers, so we're interested in the errors and the totals. So I pull up the calculator and turn it on. I'm going to come to tests, and I can either go up or down. I sometimes go up because it actually is, I'm going to B, which it can either go down a lot or up a few. I want a 2 proportion Z interval. So the first one was the written, so 1, 4, 7, 8 out of 3, 8, 4, 8. The second one had 254 out of, wow, that's a huge difference, 3, 8, 4, 8. And I was interested in a 90%, yeah, so 0.9. And I say calculate, and this gives me, well, look at this difference between p hat 1 and p hat 2. 38% errors with written versus 6.5% with the electronic. That's a huge difference. So I'm looking between, we want 3 decimal places, so I'd say 0.304 and 0.333. 0.304 to 0.333. Let me just double check the calculator. Yeah, 333. Is it plausible there's no difference? Okay, I don't see 0 anywhere in this confidence interval, so I'm coming down here and telling it no and submitting the answers. Okay, and it tells me I'm correct. Now let me show you something that's a little bit harder than this one. This one actually gave me the numbers. So let me come back up to this problem right here. We have proportions with numbers and best estimates. Now I actually went through and looked at the answers, and I'm doing this to show you where some rounding errors came up for me. But again, let me pull up my calculator. Not this one. This one. So stat. Test. I need the 2 proportion Z interval. Okay, so I'm given 22% of 41. So that one looks like 9. So right there I've got a little bit of rounding. So 9 out of 41. And then the second group was 0.32 out of, oops, I don't need it as a percent, I need it as a number. So I times 98. So we're going to have some more rounding here. So that I would round that one to 31 out of 98. And they want a 90% confidence interval, so I keep that 90 and say calculate. So let me show you what the answer from the calculator versus the answer with the Wiley Plus. You can see that this one was right on. This one was a little bit high. Remember how I had to round down for that second one? 32%. I had to round that That was a third of, are we talking people here? What are we talking about? Okay, we don't know. So that's why it came up a little bit high. So I actually went through and you can see that 5 out of 7 attempts used. It's okay. No problem there. I'll go ahead and do one more so you can see the bootstrap, the calculator, and I'll actually try to do the formula. Okay, so find a 95% confidence interval for the difference in proportions using stat key and use the formula. So difference in proportion who use text messaging for teens and for adults. Okay, so bootstrapping, difference of proportions. And when I edit the data, I have to put in the count again. So let me pull up those numbers. So 87% and 800. Okay, so 0.87 times 800. Just wondering if, no, it's not going to do it for us. So I have to put that in the calculator. So why don't I just go to the calculator to begin with. Okay, move this up a little bit. On stat tests. Z interval for two proportions. So 0.87 times 800. Oh, that came up very nicely. So 800. So 696, and then the adults were 0.72 times 22. Well, that's clear. 0.72 times 2252. Okay, I'm going to have to round that. And so I'm going to get probably a little bit of rounding error right there. So 1621 out of 2252. And we want a 95% confidence interval, so I'll change that to 95. And come down and say calculate. Okay, so 87, 70, yeah, a little bit lower. There we go. So between 12 and 18%. Let me just go back to stat. Make sure my numbers. So 696 and 1621. Oh, great. 1621. And I just forgot what my numbers were. I'm pulling up my calculator as well. So let's see. 1621. I'm going to move it off the screen because stat key will. So it's still there for me. I'm looking at 2252. And let's see. 696 and 800. Okay. So a couple thousand samples. You notice we're right here around 15%. That is the difference between the two proportions. And, okay, and so I can just do two-tail, 95%. Comes up between, I'd round that to 12 and 18%. So it looks like about the same answer. When you're using the formula, it sometimes makes sense to kind of work in simple pieces. So if I start off with just the standard error, so here's the first proportion and then 1 minus that proportion divided by the sample size. Second proportion times 1 minus that proportion divided by sample size. So I'm just going to do square root and give me a parenthesis. So actually I'm going to put in another parenthesis because I've got a plus in here. So I put in, okay, so 0.87 times 0.13 divided by 800. And then I close the parenthesis, and then I add, and then I put in another parenthesis, 0.72 times 0.28 divided by 2252. I close the parenthesis for this term, and then I close the parenthesis once more because I'm taking the square root of all that. So there's my standard error. So 0.1. And this is where it starts to get really frustrating because how many decimal points do you need to go? Well, because I've taken the square root and the answer needs to be in 3 decimal places, I'm going to write down 4 decimal places. Move this out. 0.015. Calculator, come back. I'm sorry. 152. Then, once I have the standard error, the margin of error is, since it was a 95% confidence interval, I multiply that by 1.96. So with the calculator, I can just say times 1.96. So 0.298. No? Yeah. I want to keep it with 4 decimals because I haven't got my final set. 0.0298. And then I need to know what my p hat 1 minus p hat 2 was. I gotta go back to the Wiley plus question. Let's see, we're looking at 87 and 72, so that's 0.15. And then I can put it all together, so 0.15 plus, plus minus, there's just no good way to write it. How about this way, plus slash minus, okay, plus or minus 0.0298. Calculator time. 0.15 minus 0.0298. 0.15 plus 0.0298. So again, I'm looking between 12 and 18%. Phew, it worked. All right, good luck.